Okay, here goes then. The first thing that you would be expected to do is to integrate a piecewise function. Now, you don't have to have a picture, but a picture for instruction purposes might come in handy. So 4 over x is a rational function. It's the one with the asymptote at 0. The 4 would stretch it a little bit, but it would still have an asymptote at 0. So it would look like this until it stops at 4. What's the y value when it stops at 4? 1. I agree. Okay? Now that's a closed circle. And we're all good. Now, what about the line? It picks up at 4. At 4, what is the value of the line? When x is 4, the line is at 1, and it has a slope of -1, yeah? Now that sharp turn definitely makes a difference for the derivative, but for the integral, it doesn't matter. Furthermore, it doesn't even matter if it's continuous to integrate this. If, on the next case, you get a piecewise, and it looks like this, you can still integrate and find area under the curve, even if it's not continuous. You'll deal with improper integrals in top 2, but for now, it's okay. Just know that it just kind of goes to whether you use left hand or right hand, you get the same area. So the fact that that point doesn't exist doesn't mean anything, because you could use a left hand rectangle once you get the area. All right, so write yourself a note. Doesn't even have to be continuous. I know it feels like you're breaking math, but again, left hand, right hand rectangles, either way, it would be all good. So if I go to do the area from -1 to from 1 to 5, then I'm talking this here. Now, if it's the case you have a piecewise function, then you have to integrate in pieces. From 1 to 4, you will use 4 over x. But then from 4 to 5, you will use -x plus 5. You follow? What's the antiderivative of the first piece? 4 natural log of the absolute value of x, which the absolute value wouldn't be necessary here because we're in the positive territory anyway. And the antiderivative of the other piece. -1/2 x squared plus 5x from 4 to 5. We do our thing. 4 log of 4 minus 4 log of 1 plus -25 plus 25 minus, what do we got there? Maybe -16 plus 20. Okay? 4 log of 4 is fine the way it is. What does 4 log of 1 go to? 0. Let's say the total of the halves is -25 halves plus 16 halves is -9 halves. And the total of the constants is 5. If I'm not mistaken. And it's something like 4 natural log of 4. And then you got 5 minus 4.5 is 1/2. Right? I suppose I could have done a triangle area geometrically for that, but I didn't even see it till just now. You with me? Okay. So then, if you integrate a piecewise, you integrate the pieces. No big deal. Second idea. What about, now you've done derivatives of piecewise a little bit, but this is sometimes combined with other calculus ideas, and it starts to get a little hairy. So take a look at this. First of all, you should be able to do A. Do you see where I'm at? It's an example below the line there. Okay. Would you show part A on your own? You should be able to do that, no problem. How many conditions for continuity? 3. Left hand, right hand, point must all be the same. agree that the pieces are meeting and the point is defined. Okay, cool. Now then, let's talk about absolute max of this function. What's the typical starting point on an absolute max question? EVT, yeah, the extreme value theorem says that there's an absolute max at endpoints or critical numbers. Critical numbers, it's crucial that you remember the true definition of critical numbers. They're numbers in the domain where the derivative is 0 or undefined. All right. Now then, we'll need to collect the derivative, surely. The derivative is what on the top? 2x plus 1 for x less than equal to 0. I'm not so sure because there might be a sharp turn there. The derivative might not exist at 0, right? What does the slope want to be as we leave off there? What's that slope going to be at 0? The slope is going to be 1 at 0. So this is a parabola, and as it leaves off, the slope is going to be 1. Now let's look at the other side's slope and see if it's a totally different slope. What is the derivative of the second piece? And that's for x greater than 0. Now what is that slope going to be when it picks up? At x equals 0, that slope is -2. So are the slopes the same on either side? They are different. So should the derivative be defined or existing there? No. Okay, so now let's get our critical numbers. First of all, f prime is undefined at x equals 0. So there's one critical number right there. The sharp turn we're getting at the piecewise juncture, there's a critical number. All right? Think of it like this. I mean, if I went like this, wouldn't that be an extremum? Right? Possibly. But then again, maybe it's not an extremum. Maybe it goes like this. So we'll investigate further. Don't sweat it, but it's a good candidate is the point. All right. The other possible places are where f prime equals 0. Well, let's look at each branch. Does either place have a horizontal tangent? The parabola, for example. 2x plus 1 equals 0 at x equal -1/2, and that is in the domain of that function. That function does exist at -1/2, right? Right? And then what about e to the -2e to the -2x? Does that equal 0? Ever? No. All right. So our candidates are the endpoints x equal -2 and 2, and the critical points x equal, what are our critical points again? -1/2 and 0, right? All right, great. Now then, what do I do? Am I done? Okay, so now what do I do? You plug them in the appropriate places to find their values. So f at -2, how low or high is that y value? We need to see. So f at -2, which branch do I use? Okay, so that's -2 quantity squared plus -2 plus 1, which is 4 minus 2 plus 1, or 3. Okay? F at 2, which branch do I use? E to the -2x. E to the -2 times 2 is e to the -4, or think 1 over e to the 4th. That's roughly 1 over 3 to the 4th-ish. That's 1/81st. It's pretty small. You with me? Okay. -1/2. Which branch do I use? The parabola. So -1/2 squared plus -1/2 plus 1 is 1/4 minus 1/2 plus 1. And how does that come out? 3/4. Okay. And f at 0. What is f at 0? Yeah, the continuity is all over the place. It's lousy with the fact that f at 0 is 1, right? All right. So we have, here's our 4 y values. From that we conclude the absolute max is 3, because 3 is the greatest of the candidates, or because 3 is greater than the next greatest, which is 1, which is greater than the next greatest 3/4, which is greater than 1/3, or just because it's the greatest of the candidates. You follow? Okie dokie. Last but not least, this one is a little bit trickier here. All right, so piecewise. When you integrate piecewise, and I'm talking not finding a definite integral, but actually trying to get what the function is. You know, it's not like I'm just trying to find an area on the curve like I did in example 1. This is I actually want the antiderivative piecewise function, right? Then it's a little, there's a little bit of a gotcha to this, all right? Now, as you might expect, we're going to get f by integrating, right? So if I integrate the first branch, then it's 1. And this will apply from 0 to 2. Are you with me? Now the antiderivative of that is x plus c. And they tell me an initial condition that applies to this domain. At 0, y was 3. So 3 equals 0 plus c. That tells me that the first branch seems to be x plus 3. Very cool. Now that applies from 0 all the way to 2. Includes. Now, it's a continuous function. So that branch that I just found, which is a line that looks like this, when it hands off to the other function, they're supposed to meet. It's continuous, right? So I need to integrate the next function, but the point I'm going to use is different, right? So stick with me. On the next integral, when I go to integrate the next function, it's negative x plus, I'm going to call it c2 because it's not the same constant here. Do not use 0 to 3. Why not? Does that point apply to this domain? X equals 0 isn't used for that function. So that is not a function or a point that applies. What point can you use to find c? We need to find something. What's a point? We just said they have to, where this leaves off, the next one has to pick up. So find the end point of the first branch. When x equals, where are they meeting? Where's the next one picking up? At what x? 2. When x equals 2, the first branch, x plus 3, will equal 5. They need to meet at the point 2, 5. Now the graph obviously makes that pretty clear. So the point 2, 5 should be a point on both. Now because 2, 5 is a point on this branch too, I can say 5 needs to equal negative 2 plus c2, and therefore c2 is 7, and my other branch is negative x plus 7, and that's from 2 to 4. Now I already included it. It's continuous, so it doesn't matter which branch you include it on 2. I mean, I included it on the first, but you could include it on the second. Are you with me? Okay. This, by the way, is a mistake. This should be strictly less than. Sorry about that. Okay. So this graph would look something like this. It would want to start at 7, but it doesn't. It just picks up here and has a negative slope like that. Okie dokie. That's integrating a piecewise. I actually think you should probably practice that once on your own. So try that one first which is to say number 4. Will you do number 4 right below it and see how it goes? Feel free to talk it over with your math amigos. How are we doing? Did you get 1/2 x squared plus 3 for your first branch? Good, you're on the right track. So this first graph is a parabola shape that looks something like this. And at x equal 2 is where it is told to stop, right? All right. Now, in order to get a point that you can use, do you agree that when you go to integrate the second one, you need a point to find the constant integration? The point you use has to be the point where that starts up. So you need to find, besides the x2, which you know, you need to know what's the y where this one leaves off. So I'm plugging 2 into my first branch. That's what 5 comes from. Okay? So in order to find the second constant of integration, you need to know where the first branch leaves off, which is the 0.25, yeah? If you put 2,5 into your second antiderivative to find the second constant, do you get negative x cubed over 3 plus 23 over 3? All right, that's the idea. Are you with me? Okay, you should be good to go. If you could knock out the other 3 or 4 problems, I will be walking around. If you're confused, let me know what I can do to help you. Yes. Yes. Number 3, shucks, I think I, sorry. Number 3, is it too late to make a small adjustment to number 3? Yes, it is. No, it's not. No. Number 3, the second branch is sine of x, not cosine of x. Number 3, the second branch should be sine of x, that way it's continuous. Otherwise, it's not continuous. Yes, we can work together, people. Listen to all that chit chat. Good job. Yes, I'm being facetious. Don't work together when you can. No, you don't talk now. Yeah. I'm nice. I wouldn't do the yeah, it is. Use that. What do you think about me?
I don't like it. So can we
Yes, you do.
partners?
No.
What I heard is an overwhelming yes. So what I heard all of us 3 so fertilizer this week. Did you hear that?
I do need fertilizer. It is that season. How much is it?
A partner test. That's
It's a
how
baseball
much it
partner. That's a good fundraiser. Everybody needs fertilizer.
is. With the whole partner test.
Everybody needs a partner test more than they need
No,
fertilizer.
they don't.
Great.
I'm going to use my mathematics.
Yeah, it's not necessary.
It's necessary. It's going to be necessary.
It's going to be over the homework if you've been doing the homework.
Yeah, it's true. You did.
Not really.
All right.
No, no.
How do you do number 2?
Just like the example.
You can't.
I know. How's it different?
Because it says 2 over. It's not in W.
Oh, it might help us. think of it numerically. You could make it a piecewise or graph it. What do you know about when 2 minus x is positive? What would that expression come out? When 2 minus x or x minus 2 is positive, let's just go here, shall we? I'm not sure. Let's do some points. Give me 2 will be an interest.
Yes.
All right. What about it? What's going on?
4.
Yeah. What does it equal? Negative 1. Okay. What about a 0? Was it equal to 0? Okay. What about negative 1? Still negative 1. Okay. For every number less than 2, the top is positive, the bottom is negative, but the difference is the same. So they're the same number, but different signs. So they're all negative 1. And when x is greater than 2, the top is positive, the bottom is positive, the difference is the same number, so it's positive. It might help you to think of 2 rather as a piecewise if you just graph it. In fact, you could do the integral geometrically if you have a graph. Yep. Yeah. You don't need the homework, do you? Oh, yeah. Let me just print out another one. Be less time to try to. How'd your visit go?
Pretty good.
Where'd you go again?
I went to
Gotcha. Play
Yeah.
play basketball? Okay.
We did.
Where is it? A-B test. Doo-doo-doo. Pages. Which one? Do you see the graph? Shade the region and just do the area geometrically. See what I mean? What do you mean? What the heck, Laney? What's the integral from?
It's not minus.
It's from 1 to 3? Area. Oh, that's signed area. These are negative y values, so this looks good.
Okay. Is that it?
That's
That's all the mark.
That's it.
That's really? Really, that's not all the plus one. I get it. So the test is I got I got 3. It's only like where one of us messed up.
So 9 days of break isn't enough. You got to take 2 more. I don't know yet. There you go. Oh. Yep, you said that. Yes.
I'm trying to find the correct numbers, but I just have a hard time.
So that means there is no.
Yeah, I did.
So, whatever it is, zeros are exercise 7.
What is that?
Yeah.
Kind of one.
Kind of decent.
Kind of pi is zero. Yes, I know.
Hi. Yeah. Actually, I would write. Um, you bet. What number is on the back? Are you on the back? That's 5. 5. I might shorten it up a little to save you some time. Think about that. That line has a intersect. You don't even know. So it's this one.
Do we not know it?
So you would have to, if you were, I'm going to scratch this, but because you're smart, if you were to write this, it'd have to be something like y minus 1 equals, so it comes maybe 10. X minus 7, so it's asked us to do like 20 minus 10. Or negative 10x. So you got there something like plus 9. That's the equation of that one. I wanted to know what the equation was.
Because that's 2.
So I'm going to, so I got to change your type of it, but I'm going to scratch that.
Draw that now.
Scratch that, don't worry about it. Okay. On number, oops, where am I at here? Sorry. Nope. Darn it. On this guy here, on the back, let's clean it up a little. I'll make your life a little easier. This segment here, on the downslope, and this little guy, you can scratch those out. Just do those 2 segments, okay? Just scratch from above x equals 7, just don't worry about that part of the graph. What? You will need a new point, yeah. Now keep in mind that's the derivative, not. Yes. Yes. So how do you write a horizontal line? So y equals a constant. Told you. Yes, ma'am. Sure.
Regular, and then you have to find, like, you have to find C, and then you have to do it. So it's just like what you just said.
No, yeah. It is.
No, that's not.
Yeah, and that's still great.
Oh, actually, that's part A. No, that's right. You are done for 30 minutes. Yeah, I would do a graph. You could do a graph.
So what are you putting in? I minus, and this one.
You're right. It is.
And it looks 20x. How did you get, oh. So C's negative 10, negative 30.
Oh no, we did.
Okay, now I got it. No, I don't.
No, we're right. No, it's okay, Jasper. It's 15 minutes.
Yes.
I thought we called 7 or 6 faster.
From the 30-minute mark to the end of the period. I'm 30 minutes in. That's 30 minutes in. So the first branch is from 0 to 10. And then the next branch is from 10 to 21 minutes. And from 30 on to the end. $7.48. Okay.
So I had already looked through the grossness of that problem by the time you deleted it. So could I like skip B number 6 or something?
No, that's fine.
Good try though.
How long is study hours?
40 minutes.
40?
How could you be a senior and still?
Oh, I thought it was 35. I've been here for 6 years.
Unbelievable. Okay. Thing is, I'd like to take about 10 minutes to just jot down a few review notes for the test review before we move on. Could you just get that to me before tomorrow or by tomorrow? Yes. Okay, sounds good. If you want to keep working and blow off test review, fine. If you want to jot down a few notes on test review, here we go. Okay. So, values around horizontal and vertical lines. The first thing I beg you, please understand that a horizontal x equals a constant is a vertical line. Y equals a constant is a horizontal line. If you misidentify the axis of revolution, there is no way you'll get the right answer. You've got to draw the picture right. Okay? Second, you choose the variable first based on what's easier or what is only one integral. Okay? When you go to do one of these volumes, you say, which one do I want to use, x or y? You then draw the region and the slice. When you use x, your slices look like that. When you use y, the slices look like that. Then you revolve a slice. And after that, then and only then, you say what's made. A shell, a washer, or a disc. Okay? That is the last part of the problem, not the first. You don't look at the problem and say, I'm going to use shells. It doesn't work that way. You say, I'm going to use x. And when x is revolved, it makes a shell. That's how the process works. And then I beg you, use right minus left to make a positive distance here, and upper minus lower to make a vertical distance here. Let me make this also clear. Many of you, when you did that 94 extra practice worksheet, you got the right answers. Your integrals were 100% wrong. Because the square in a washer often negates that sign error. You sometimes will get the right answer because your big R was negative, but because it was squared, it was a wash. Well, I absolutely will count off if your integral is garbage. I don't care if your answer is right. Your integral better be right, or you will lose points. Understood? Make stuff positive. The answer will take care of itself. All right, moving on. Newton's method. It is used to find zeros. The first thing you do is make it a zero problem. For example, if I wanted to solve cosine of x equals x using Newton's method, that's not a Newton's problem. There's no zero component to this. What's the first thing you do? You subtract it one side so that now it's a zero problem. You let f equal cosine of x minus x. Now you're finding a zero. This problem here, as it is not a Newton's problem. You can't even use it. You have to make it all on one side, and then it's a Newton's problem. All right. Second, make sure that you study and know Newton's formula. X1 is x initial plus or minus? Minus f or f prime on top? F over f prime. Okay, it's minus, not plus. Please show the derivative somewhere in your work. I see sometimes people say, f prime, you never told me f prime. I have to see f prime. Okay? Derivatives of inverses. The derivative of an inverse is 1 over the normal derivative at the inverse point. Usually this can be found by guess and check. But basically, you'll be given this value at which they want the derivative. This is the y of the original function. So for example, if I wanted the inverse derivative at 2, that means 2 is the y value in the original. I need to find the x before I can do anything. Okay? Moving on to 91. The two indeterminate forms are infinity minus infinity and infinity times 0. If you say infinity times 0 is 0, you're pretty much, you wasted your time because you'll get 0 on that question. You don't know anything. Okay? Those are indeterminate forms. The first thing you do is make it a quotient. You don't take derivatives on that form. You don't take derivatives on that form. You don't take derivatives on that form. You make it a quotient. You then show L'Hopital work, and I'm talking good L'Hopital work, not this 0 over 0 off to the side garbage. I did not teach you that. I taught you to identify the pieces well and the limits separate. Okay? Many of you are going to hurt on that one because grading last night's homework, it was 85. I'm not going to get distracted, but it was terrible, terrible. And you didn't even have a clue. Okay. Distance, displacement, average position. Distance, what is distance? Absolute value. What is displacement? V, okay? If I asked you if I said, I gave you a problem like this here, and I said, what does it mean? It was on the extra practice. What does it mean? Is that the average distance? It's not the average distance. It is the average of whatever's the function. And so it's the average of the function, which is velocity. I understand this is displacement. I understand you're confused, and I get it. But it's not the average of this whole thing. It's the average of the function within the interval. So it's the average velocity. And 1 over b minus a is the absolute value is the average speed, not the average displacement. It's the average speed because it's the average of the function in the interval, and that is the speed. Okay? You need to be able to write in this piecewise and do that.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Students and staff tomorrow is Brown's last day to count. She was moving to a new school. Please stop to say goodbye and good luck at her new location.
The Colorado State Patrol Youth Academy is accepting applications until this Friday, March 22nd. Cadets will become familiar with the basic elements of the academy through a demanding daily training schedule. It's limited to 45 participants selected throughout the state. The application is online. The academy will be held on July 14th through the 20th.
Dad, the day is here. Sign up for 7th hour. After attendance is taken. Report to the cafeteria for cheering information. Come see if cheerleading is something for you. Bring a friend and see you there.
Are you a female interested in learning more about a career in the law enforcement field? The Jefferson County Sheriff's Office Women Law Enforcement Career Fair is on Saturday, April 6th at 9 a.m. at the Jefferson County Sheriff's Office in Golden. Counseling has the details.
University can boast 360 days of sunshine as the southernmost ski area in the U.S., a foodie paradise, and much more. The University of Arizona from Tuscany will be in counseling today.
Please make sure you differentiate between when it says mean value theorem for integrals and mean value theorem.
Attention all 8th through 11th graders. This Thursday, cheer
It says mean value theorem, and that's the derivative equal average rate of change idea. It has no descriptor, that's in fact the derivative of the t.
something you're interested in.
It says mean value theorem for integrals, that's the average value idea.
Blood drive is coming up on April 2nd.
Good.
Sunday blood can save up to 9 lives. Stop by lunch next week to sign up for a slot. You must be 16-year-old deduction.
It will be online.
Senior high students.
Not yet.
Junior should.
Ready?
Don't miss April 10th at 10
Hey,
p.m. at Dunwoody.
788's pretty old, but make sure you know this.
Well, how about you go into your college studies for the next year of junior should. Learn how to best engage your college and how to best navigate the college admissions process. Attendees will be eligible for once an hour private consultation with Ms. Allen. Participants are encouraged to attend.
Seniors, another great scholarship for you. The Colorado County Clerks Association's 2019 annual scholarship. The selection criteria is based on extracurricular, community, and service activities with demonstrated financial need or hardship. Deadline March 29th. Stop by Catholic for details.
Any current 10th and 11th graders who are interested in becoming a girls mentoring leader next year, please come to the counseling office to pick up an application. Leader applications are due this Friday, March 22nd.
Seniors, CES scholarships are due to counseling the Wednesday after spring break, April 3rd by 3 p.m. Make sure you have all your teacher recommendation forms and an amazing essay with resume. Any questions, stop by counseling.
Seniors, the JCEA 2 and Burger Scholarship.
I think that's it.
$1,000 for 4 years focuses on students pursuing degrees in physical sciences. In addition, the JCEA High School Scholarship worth up to $4,000 for 4 years. These are great days through 12th grade schedule. Those scholarship deadlines are extended to April 5th. See details on the scholarship holding for you past year.
Senior high students, National Senior Honor Society will meet this Friday in the cafeteria, and we have a lot to share.
Sorry.
Please consider the great family conference.
Saddle and Jack, our Lady Jack, defeated the Florida Heat Mavericks last night in Lakewood Memorial Field 4-1. Let us have one and a half.
Have a good day.
Kira has 4 saves and goals.
Hey, Kira Hess had 4 saves and goal.